Text mining involves the process of extracting useful information and insights from textual data. One of the essential techniques in text mining is text clustering, which is used to group a set of documents into clusters of similar documents. This non-story content explains various techniques used to achieve effective text clustering. Text clustering can be broadly classified into two categories: hard clustering and soft clustering. In hard clustering, each document is assigned to exactly one cluster. On the other hand, soft clustering, also known as fuzzy clustering, allows each document to belong to multiple clusters with varying degrees of membership. K-means clustering. This is one of the most commonly used algorithms for text clustering. The K-means algorithm assigns each document to the cluster with the nearest mean. It starts by selecting K centroids, which are the initial points for each cluster. The algorithm then iterates through assigning documents to the nearest centroid and recalculating centroids based on the current cluster assignments until convergence. Hierarchical clustering. Unlike K-means, this method builds a tree of clusters called a dendrogram. It can be agglomerative, which means each document starts in its cluster, and pairs of clusters are merged as one moves up the hierarchy, or divisive, starting with all documents in a cluster which are iteratively split into finer groups. DBSCAN, density-based spatial clustering of applications with noise. This method focuses on finding dense areas of data to determine clusters, making it ideal for data with noise and outliers. It does not require the number of clusters to be specified, as it can find clusters of varying shapes and sizes. Latent Dirichlet Allocation, LDA. Primarily used as a topic modeling technique, LDA can also be employed for clustering by identifying groups of words that frequently occur together across different documents and forming clusters based on these topics. Self-organizing maps, SOMs. This neural network-based technique uses a grid of nodes to represent clusters. Documents are mapped onto this grid based on their similarity, and the nodes adjust to represent the underlying structure of the data. Each of these techniques has its merits and is selected based on the specific requirements of the text mining task at hand. For instance, K-means is computationally efficient and useful for large datasets, while hierarchical clustering provides a more intuitive understanding of the data structure. In conclusion, text clustering is a powerful method in text mining for organizing large sets of documents, uncovering hidden structures, and revealing insights. The choice of clustering technique will depend on the dataset characteristics and the goals of the analysis. With the advancement of natural language processing, these clustering methods continue to evolve, offering more sophisticated ways to analyze textual data.